In this video, I'd like to present a formal definition of limits, and we do this by using one-sided limits. So approaching a from the left or approaching a from the right. And you will see we have examples where this limit from the left and from the right is actually not the same. So let's look at this function here. It is a combined function of several well-known functions. For example, this here is y equal x squared. This here is y equal x. And then this bit is y equal 3. And they have been combined at those intersection points. So at 0, I took out the value 0, so the function is not defined at 0. And then at the value x is equal to 1, the function is equal to 1. So the black dot indicates this point belongs to the line y equals x, and the open circle indicates it does not belong there. So I like to look at three limits. I like to look at limit a is equal to minus 1. I like to look at a is 0. And I like to look at a is equal to 1. And of course, all these cases are different, so it does make sense to talk about them. So let's first look at limit as x goes to minus 1 f of x. So the function has a value here, which is equal to 1. And then also, the function is just well defined, so you can plug in any numbers. They're all part of the function. So here, this actually equals f of minus 1, which is minus 1 squared, which is 1. So in this case, when a is minus 1, we can easily compute the limit. How about at 0? If we say x goes to 0 f of x, well, in this case, if I come from the left, the parabola converges to 0. If I come from the right, if I take values which are bigger than a, I'm on the straight line, and I also go to 0. So 0 is not part of the function, but the limit does exist, right? It converges to 0 just by the graph. And then finally at the point 1, now if I approximate 1 from the left, taking values less than 1, then I approximate the value 1 right here. If I take values bigger than 1, come from the right, I actually stay at 3 all the time. So it seems like from the left I get 1, doing this from the right I get 3. So in this case we say it does not exist because the left and right-sided limits do not agree. Let's use this in a definition. We first define one-sided limits. So I call a limit x to a minus f of x equal to L1 if f gets close to L1 as x approaches a from the left, or sometimes we say from below. And this is the indication of the little minus on the a, it means from the left. And then if we use a little plus on the a, we converge from the right. And then we define the limit to be L, so the limit to a where there is no plus or minus on the a thingy is equal to L if the right and left-sided limits exist and they are equal. So we want the limit from the left and the limit from the right to be equal. If this really happens, then we say the limit exists and is L. In this example, let's do this for minus 1. Let's look at the left-sided limit, limit x to 1 minus. I come a little bit from the left, okay. And in the other case, I come a little bit from the right. And in either case, I converge to 1. So they are the same. So we say the limit exists. Let's look at 0. Okay, so here we see in both cases, we converge to 0. So these limits are the same. So we can say the limit as x goes to 0 is 0. And of course, it's different at the point 1. If you approach 1 from the left, so from here, okay, then you converge to 1. If you approach it from the right, so from here, you get a 3. Okay? So they're not equal, so we say the limit actually does not exist. Let me summarize. So we say a limit exists if the limit, the left-sided limit, and the right-sided limit are all the same number. And the limit does not exist in either of two cases. So it could be either that the left-sided limit is unequal to the right-sided limit, or if the left-sided limit or the right-sided limit are one of plus or minus infinity, then we also say the limit does not exist. We will see examples later where this also happens. Let's see what Gerlach and Marlowe are up to.